If you could watch the universe from its beginning, compressed into something your eyes could follow, you would see darkness first. Not the darkness of night, but something older and more complete. And then, slowly, almost reluctantly, you would see light beginning to gather. Not all at once, not everywhere, just in certain places, for reasons that had more to do with slight imbalances than with design. Galaxies did not arrive as finished objects. They emerged the way landscapes do, shaped more by patience than by force. What we see now, when we look at a spiral galaxy turning in the night sky, is not a thing that was built. It is a thing that survived. The early universe was simpler than it is now. After the first few 100,000 years, when light could finally travel freely, matter was spread almost evenly across space. Hydrogen and helium, distributed in a fog so thin that most of it would qualify as vacuum by any standard we use on Earth. But almost evenly is not the same as evenly. There were places where the fog was slightly denser. Regions where, for no particular reason, there was fractionally more matter than in the regions beside them. Gravity does not require much to begin its work. It does not need intelligence or intention. It only needs difference. Where there is more mass, gravity is slightly stronger. Where gravity is slightly stronger, matter begins to drift inward. Slowly, over millions of years, the denser regions became denser still, pulling in gas from their surroundings. And the process fed itself. This is how structure began. Not through sudden events, but through accumulation so gradual that if you had been there, watching a single location for a human lifetime, you would have seen nothing change at all. By the time a few 100 million years had passed, the first stars were beginning to form inside these denser pockets of gas. They were not like the stars we see now. They were massive, short-lived, and they burned through their fuel in what amounts to an instant on cosmic scales. A few million years, perhaps. When they died, they exploded, scattering heavier elements into the surrounding space. Carbon, oxygen, iron, the raw materials that would eventually make planets possible, though that would not happen for a very long time. These early stars did not form in isolation. They formed in clusters, drawn together by the same gravitational wells that had pooled in the gas that made them. And these clusters, over time, began to merge with other clusters, not quickly. Mergers between groups of stars happen slowly, over hundreds of millions of years. They collide, pass through one another, exchange momentum, and eventually settle into something more stable. What looks like structure is often the residue of countless small movements spread across impossible stretches of time. The first galaxies, if you could have seen them, would not have looked like the galaxies we know. They were smaller, more chaotic, less organized, clumps of stars and gas, loosely held together, still in the process of deciding what shape they would take. Many of them did not survive. They were pulled apart by their neighbors, or consumed by larger structures, or simply dispersed back into the darkness. From a distance, formation appears calm, even orderly, though nothing about it was hurried or intentional. Galaxy formation is not a single event. It is a process that unfolds across billions of years, and in many ways, it is still happening. The Milky Way, the galaxy we live in, is still growing. It is still pulling in smaller galaxies from its surroundings, absorbing them, adding their stars to its own. This has been happening for as long as the galaxy has existed, and it will continue for as long as gravity operates. When two galaxies merge, it does not look the way collisions usually look. Stars are so far apart, even within a galaxy, that during a merger, almost none of them actually touch. The galaxies pass through one another like two clouds of smoke, their stars gliding past each other with vast distances between them. What changes is not the stars themselves, but their orbits. Gravity pulls them into new paths, new configurations. Over time, the two galaxies lose their original shapes and settle into something new. The Andromeda galaxy is moving toward the Milky Way. In about 4 billion years, they will begin to merge. It will take another billion years or more for the process to complete. By the time it is finished, the night sky from Earth, if Earth still exists, will look entirely different. The stars will be rearranged. The structure we know will be gone, replaced by something larger and less symmetrical. But this merger is not unusual. It is ordinary. It is what galaxies do. The scale is so large that cause and effect feel separated, as if action and outcome rarely occupy the same moment. Most of what shaped galaxies happened long before anything resembling life appeared anywhere. And even now, most of it happens in places where no one is watching. In the space between clusters of galaxies, where the distances are measured not in light years, but in millions of light years, gas drifts slowly inward, pulled by gravity toward the densest regions. It takes tens or hundreds of millions of years for this gas to fall far enough to begin forming stars. By the time it does, the conditions that set the process in motion are ancient history. Much of what shaped galaxies happened in silence, without observers, without records, without urgency. The shapes galaxies take are not arbitrary. Spiral galaxies have their shape because they are rotating. As gas falls inward, it does not fall straight down. It has angular momentum, inherited from the slight rotation of the region it came from. This causes the gas to spiral inward, forming a disk. Stars form within this disk, and they continue to orbit in roughly the same plane, creating the flat structure we see. Elliptical galaxies, by contrast, have little or no overall rotation. Their stars move in all directions, creating a shape that is more spherical or elongated. These galaxies tend to form through mergers. When two spiral galaxies collide, their disks are disrupted, and the stars are scattered into more random orbits. What emerges is an elliptical galaxy with no clear structure, no spiral arms, just a smooth, featureless glow. There are also irregular galaxies, which have no clear shape at all. These are often smaller galaxies that have been disturbed by their neighbors, or galaxies that are still in the early stages of formation before they have had time to settle into something more organized. But these categories are not absolute. Galaxies change, they evolve. A spiral galaxy can become an elliptical galaxy if it merges with another galaxy. An irregular galaxy can become a spiral if it is left alone long enough to organize itself. The shapes we see are snapshots, moments in a process that unfolds over timescales we cannot directly observe. Time does not pass evenly here. It pools, stretches, and thins until change becomes almost imperceptible. One of the things that shaped galaxies, though we cannot see it directly, is dark matter. This is matter that does not emit light, does not absorb light, and does not interact with ordinary matter in any way except through gravity. We know it exists because galaxies rotate faster than they should, based on the visible matter alone. The stars at the edges of galaxies move as if they are being held in place by far more mass than we can see. Dark matter forms halos around galaxies, extending far beyond the visible stars. These halos are what provide the gravitational framework within which galaxies form. Without dark matter, the gas would not have clumped together in the first place. The universe would be far emptier, far more uniform, with no galaxies, no stars, and no planets. But dark matter does not explain everything. There is also dark energy, which is causing the expansion of the universe to accelerate. This means that the space between galaxies is growing, and the rate at which it is growing is increasing. Galaxies that are not gravitationally bound to one another are moving apart, and over time, they will move apart faster. Eventually, billions of years from now, distant galaxies will be moving away from us so quickly that their light will never reach us. They will disappear from view, not because they have been destroyed, but because the space between us and them has grown too large. Patterns emerge not because they were planned, but because randomness had enough time to repeat itself. The structure of the universe, on the largest scales, resembles a web. Galaxies are not distributed evenly. They cluster together in groups and superclusters, connected by filaments of gas and dark matter, with vast voids in between. These filaments stretch across hundreds of millions of light years, and the voids are equally large. If you could see the universe from a great distance, it would look like foam, with galaxies concentrated along the edges of bubbles and almost nothing in the interiors. This structure formed because of the same small imbalances that created the first galaxies. Regions that were slightly denser pulled in matter from their surroundings, and this created gradients. Matter flowed along these gradients toward the densest regions, leaving behind areas where almost nothing remained. The voids are not empty in any absolute sense. They contain some gas, some dark matter, occasionally a stray galaxy. But compared to the filaments, they are nearly vacant. The emptiness between galaxies is not absence, but space where nothing needed to happen for long periods. Most of the universe, by volume, is empty. Most of space contains almost no matter. And most of what does exist is dark matter, which we cannot see. The stars, the galaxies, the planets, all of the visible matter we can observe make up less than 5% of the total mass and energy of the universe. Everything else is dark matter and dark energy, neither of which we fully understand. This means that the universe we see is not representative. It is a small, bright fraction of something much larger and much darker. The galaxies are islands scattered across an ocean of emptiness, and the distances between them are so large that light itself takes millions or billions of years to cross them. Seen this way, growth is less about accumulation and more about survival through vast intervals of stillness. Galaxies are not immortal. They change, they merge, they are pulled apart by tidal forces. Over time, they exhaust their supply of gas. And when the gas is gone, star formation stops. The stars that remain continue to burn for a while, but eventually they too run out of fuel. Red dwarfs, the smallest and longest-lived stars, can burn for trillions of years, but even they will eventually fade. When the last stars die, galaxies will become dark. They will still exist as collections of dead stars, white dwarfs, neutron stars, black holes, but they will emit no light. The universe will enter what is sometimes called the degenerate era, a time when all the stars are gone and only their remnants remain. This is billions of years away, trillions of years for some stars, but it is inevitable. The universe is running down. The expansion is accelerating. The gas is being used up. The processes that created galaxies are slowing, and eventually they will stop. Galaxies feel permanent only because our own sense of duration is so small by comparison. We have existed for a tiny fraction of the time galaxies have existed. Human beings, as a species, have been around for a few 100,000 years. Civilization, in any organized sense, is only a few thousand years old. Recorded history is even shorter. The entire span of human experience, from the first stone tools to the present moment, is less than a blink on the time scale of galaxy formation. And yet, we can observe galaxies. We can measure their distances, their compositions, their ages. We can reconstruct their histories, even though we were not there to witness them. This is possible because light takes time to travel. When we look at a distant galaxy, we are not seeing it as it is now. We are seeing it as it was when the light left it. If a galaxy is 1 billion light years away, we are seeing it as it was 1 billion years ago. This means that by looking at galaxies at different distances, we can see different stages of their evolution. We can see what galaxies looked like when the universe was young, and we can compare them to galaxies in the present day. This allows us to piece together a history, even though we cannot watch a single galaxy change over time. The process is slow. The changes are subtle, but over billions of years, the differences become clear. Early galaxies were smaller, more irregular, more turbulent. Modern galaxies are larger, more organized, more settled. The transformation happened gradually, through mergers, through accretion, through the slow accumulation of gas and stars. There is no endpoint, no final form. Galaxies do not reach a state where they stop changing. As long as gravity operates, as long as there is matter to pull in, galaxies will continue to evolve. The Milky Way will merge with Andromeda. The resulting galaxy will eventually merge with others. The process will continue until the expansion of the universe pulls everything apart, or until the supply of gas is exhausted and no new stars can form. What we see now is not a finished product. It is a moment in a process that began long before us and will continue long after we are gone. The silence is not empty. It is full of motion too slow to hear. When you look at a galaxy, what you're seeing is light that has traveled for millions or billions of years to reach you. The stars you see are not where they appear to be. They have moved. Some of them may no longer exist. The light is old, and the image it carries is old, and by the time it reaches you, the thing it represents has already changed. This is true of everything beyond our immediate surroundings. The moon is about 1 light-second away, so when you see it, you are seeing it as it was 1 second ago. The sun is 8 light-minutes away. The nearest star beyond the sun is over 4 light-years away. By the time you reach the distances where galaxies are found, the delays are measured in millions of years. We are always looking backward, never at the present. The present is too far away. And yet, from all of this distance, from all of this delay, we can still learn. We can still measure. We can still reconstruct what happened, even though we were not there and never will be. The light carries information, wavelengths, intensities, spectra. From this, we can determine composition, temperature, motion, age. We can map the universe, not as it is, but as it was, at various points in its history. Galaxies formed slowly. They formed out of imbalance, out of gravity, out of the patient accumulation of matter over spans of time that make human history invisible. They continue to form, in a sense, because they are still merging, still growing, still pulling in gas from their surroundings. The process has not stopped. It has only slowed, and in the spaces between galaxies, where almost nothing exists, time passes without event. The void is not dramatic. It is not empty in the sense of being hollow. It is simply space where, for long stretches, nothing needed to happen. No stars formed. No collisions occurred. Gravity pulled gently, too weakly to gather anything, and the gas drifted onward, toward denser regions where it would eventually contribute to something larger. Galaxies are not central. They are not the point of the universe. They are simply where matter happened to gather, and where conditions allowed stars to form. Most of space is not like this. Most of space is far emptier, far quieter, far less eventful. We live in a galaxy, and so galaxies seem significant to us. But they are a small part of a much larger structure, and that structure is a small part of something larger still. The scale extends outward, past what we can see, past what we can measure, into regions where the light has not yet had time to reach us. What we know is incomplete. What we see is delayed. And what remains is the simple fact that matter gathered over time into shapes we call galaxies, for reasons that are not mysterious, but are difficult to comprehend because they unfolded so slowly and on such a large scale. There is no conclusion here, no lesson to extract, only observation. The galaxies are there. They formed. They continue to change. And we, from our brief vantage point, can watch and measure and try to understand how patience and gravity, given enough time, can create structure out of almost nothing.